We are discussing derivatives. What is a derivative? What do we mean by a derivative? We talked about a derivative at a point. That means at particular point, what is differentiability? What is derivative? So the crux of the story was that when we have a function fx, it's a real valued function, and you are talking about an interval a comma b, some value at c in this interval. So if we are interested in f dash c, that is you want to find out a derivative. So essentially we are trying to find out the limit. So this is limit x tend to c, and simply the subtraction of fx minus fc, that is the value of function and the value of function at this c point, divided by the two values, the x value and the c value. This is the derivative. But this is mathematics. What do we understand when we say that this is a derivative? What does it mean when we talk about real life? We need to know the physical interpretation. We need to understand the geometrical interpretation. That is, just by knowing this formula, we can just solve questions. But if we understand derivative, then we'll be able to solve it with all our logic, right? So let me give you an example first. For example, if something is having 2 kg weight, the rate is say $10 for 2 kg. For 4 kg, what it will be? Twice of this. For 2 kg, it is $10. For 4 kg, it's $20. Now you will tell me about 8 kg and 10 kg also. It's clear. 10 kg, if it is for 2 kg, some say rice. For 2 kg, it's 10 rupees. So 10 by 2, 5. 5 into 10 is 50. So you know that this is 50. So that means if you make a graph or you have any real life situation and everything is going fine without any deviation, if something is a straight line, that is, if I ask you that you know about 2, that the cost is $10, tell me about 6. You can plot it. You can easily tell by the observation. That is, if it is 2 for 10, that is 10 by 2 into 6, that is 30. So for 6 kg, you can say kilogram, that is $30. So it's quite easy for anyone to answer this question. If it is straight, if things are very straight, if a vehicle is moving, now the average speed, say it's 40 km an hour, it's not going 30, it's not going 50, it's always 40 km an hour. In 1 hour, you will surely tell me it will be 40 km traveling, 2 hours it will be 80 km, 3 hours it will be add more 40, 120, so on and so forth. Now everything is fine up till now. When we are talking about a function, there are different type of functions. Functions are everything, that is, if you are writing y equals fx, whenever you are putting some value of x, you are getting some unique value of y. For example, y equals 2x, we put x as 2, you are getting y as 4. So you are getting a function, you have a function, you are getting proper value. But the situation here is not these ideal cases. When everything is fine, everything is going wonderfully fine, we have no problems. You and me, anyone can tell this. But if the function is e raise x, a raise x, log x, and the combination of logarithmic and these kind of functions, so the function result may be like this, then what will you do? Now if I say you that, okay, at this x, some 1 hour, 40 kilometers, as we discussed, can you tell me that in 2 hours you will be 80 kilometers? In 2 hours you will travel 80 kilometers? No, you cannot tell. So you need to have a tool. You need to have something that whether we have a straight line, whether we have a different, curvier line. If I give you a tool that I can find out that in a curve also, this kind of situation, which I was easily able to answer previously, I can find out a perfect value or not perfect, near perfect, then the problem will be solved. So this is the physical interpretation. Mathematically, let us understand this physical interpretation now. Again, I'll tell you a story now. Now we are traveling from point O to point, say, X. O is source, X is destination. Now say a vehicle is moving here. So when a vehicle is moving, it will have some speed, right? It will have some speed. It will take some time to reach point to A, point B, point C, and it will travel certain distance. All these entities, quantities, will be associated with this traveling, right? So now I can ask question about speed, time, and distance. Any other question I can ask you. Are you able to tell me that at certain point, what will be the speed, what will be the time, what will be the distance? That is, if I say that I give you a point precisely, that this is the point P, I ask you, what is the value of speed at P? Tell me. If I say you tell me the time at P, you will be able to tell me. For example, you are going to Delhi to Agra or some X to Y destination. So if P is the point, and if you go to a Q point, what will be the time? What will be the speed? What will be the distance? These are my questions for you. I don't know the speed. It's not an average speed. It's not a proper constant speed. It's changing. Sometimes you will say, so stay. Sometimes this tire gets punctured. Sometimes something else may happen. So now this kind of questions can be answered by derivation, by differentiability. So let me give you some points now. From here to here, say you reach in 1 hour from O to P. From O to Q, let us say 1.5 hour, 2 hour. It's not possible that reaching Q, it will take 1 hour, reaching P, it will take 2 hours. It will never happen because P is coming before Q. So 1 hour for P, another 1 hour for Q. That is in all 2 hours for Q. So it's dependent on time. I gave you the time. So time will increase as the distance will increase. So let us say at P, we have certain time T0. Let us assume it to be 1 hour. Now when you go to Q point, you will add some time to this T0. That is, as I said, 2 hours. So you have to add 1 to this. 1 plus 1 is 2. So actually 2 is nothing but 1 plus 1. And 1 is what? T0. And H, that is that distance you have traveled, is 1. So I'm saying from P to Q, you traveled the distance H. H is a distance. And the time at P as T0, the time at Q is T0 plus H. Now I'll ask you the question. What is the distance? As I said, the distance will be simply this, say, H. So what is the distance here? OP. As I said, OP is a function of time. I'm saying that everything is a function of time here. So let us take a function. The distance is a function of time. OP is ft0. What about OQ? Same logic. OQ is what? Function of time. So now what is the time at Q? T0 plus H. So T0, so you have taken some extra time H. Of course, you have traveled a distance, so you have to have an extra, time. Now, so you have OP and OQ. Now I ask you, what is the PQ distance? You can easily tell. OQ minus OP, as I already told you, it is a H distance. You know that it is going to be H. So what is the distance? ft0 plus H minus ft0. So PQ is the distance, right? Distance. Okay, speed equals distance by time. I just told you that distance is the function of time. So PQ is ft0 plus H minus ft0. Now what is the time? T0 plus H at point Q. T0, the time at P is T0. So 2 hour for point Q, 1 hour for P. So 2 minus 1, 1. 1 hour. So the distance I told you, we traveled certain distance. And for this H, okay, H is our T0 plus H minus T0, that is OQ minus OP for the time. The time is what? H. So the time as per this, don't worry about this distance or time. Just worry that we are finding out the distance in terms of time as a function. We are trying to find out the time for time. So this ft0 plus H minus ft0 by H. So now I want you to find out the time or distance speed at one point. I don't want P and Q. I'm just asking you, go anywhere. If I ask you the time, you have to tell me. Distance, you have to tell me. So this P and Q are two different points. Let us make them one. Is it possible that we can make this P and Q come closer, closer, closer so that become one? Right? So when this becomes very close, that is Q tends to P. That is OX, P also here, Q also here. So this P and Q, you can tell exactly the time, speed and the distance. So Q is actually tending to P, or you can say P is tending to Q. So this H is, as I explained you, I can take it as a distance, I can take it as a time, it doesn't matter. Ultimately this PQ becomes 1, H is going to be 0, there is no H because PQ are together. So we can apply the limit here, limit H tends to 0. So when we apply this limit H tends to 0, this speed, now T equals T0, T0 plus H, T and T0 plus H are same. So you are actually trying to tell me the point P and Q together, there is some point you are able to tell me the speed precisely. You can tell me the time, speed, distance precisely. This is the derivative. So this f dash t0 is nothing but f t0 plus th, t0 plus h minus f t0 by h, limit h tends to 0. This is derivative. Now I'll give you a proper example. This was just to understand, make you understand. Now let us take the actual problem. So we have the distance ft in meters moved by a particle traveling in a straight line in t second is given by a function, which is t square plus 3t plus 4. Find the speed of the particle at the end of 2 seconds. So I have given you a function. I want you to precisely tell me what is the speed at 2 seconds. Now this 2 seconds can be 3 seconds, this 2 can be 1.5 seconds, this t can be say 5, 20, 50 seconds. Now you can precisely tell me what is the value. So now if you have a different type of curve which is not a straight line, and now you can tell me that exact point whether the curve is straight or anywhere, you can tell me using this discussion. For example, the ft, so you are basically trying to find out f dash 2. That is the derivative of this function at point 2. So what is the function? F x plus c minus fc by h. Remember first discussion? So f2 plus h minus f2 by h, limit h is tending to 0. Limit h is tending to 0. So wherever you have t, just put 2 plus h. That is 2 plus h whole square plus 3 and 2 plus h here and plus 4 and this whole minus f2. That is put 2 wherever t comes. So I just put 2 t square, that is 2 square plus 3 into 2 plus 4. What do you see here? I'm not going to solve this. I'm going to give you the exact result. Okay. That is just open this. 2 square plus h square plus 2 into 2, 4h plus 6h plus 4, 6x plus 3h plus 4 minus 4. That is all will be 14. 2 to the 4, 6 and 4. So it is going to be minus 14. So this is going to be h square plus 7h because 14 gets cancelled. And then this 4h and 3h will be 7h. So h square by 7h you'll get. And of course, we have this h in the denominator. Remember, we have h in the denominator. Now h square plus 7h is going to be what? Take h common from here. Take h common. So h plus 7 it will be. H gets cancelled. H plus 7. So apply the limit. I'm taking limit here, but you have to apply in h plus 7. So 0 plus 7 is 7. So this is the 7 value, which is the derivative of this function at 2. So you are able to tell me the exact ft function or speed at time 2. If I ask you 3, 4, you are able to give you. This is the derivative. This is the actual physical interpretation of the derivative. Now, in order to understand more, let me take you a step ahead for geometrical interpretation. Well, how do you see it in geometry? Because you know the geometry, because your graph is not very straight line now. You have to have some kind of curve, and then we need to find out a derivative at a point. So the geometrical interpretation will be something like this. Let us take, everything is about function. So y equals fx is your function. It's a differentiable function. Now I want to ask you that if you have a curve like this, y equals fx. Now this is a curve. It will be something like this, not a straight line. Now y equals fx here is your function. Now take a point, certain point. And you know by previous discussion, this first point, say it's, what is the point? C is your x coordinate. What is the y coordinate? Fc, because y equals fx. So when you put this x as c, fc will be the y. So c and fc are your x and y coordinate. For example, in any graph, if you take any point, say x coordinate and y coordinate 2, 3 like this. So we are taking x as 2, x as c, and y will be fc. Now let us move ahead. Let us go ahead. So take some other point, say this point. So I will ask you, what is the value of y for certain x for this? Say I extended my distance, because this is the distance I'm traveling as we took in the previous discussion. So at this point I'm taking, what is the x and y value? This is c, say we traveled for h distance. So this will be c plus h. Okay. Now the x point will be c plus h because c is the x coordinate, you traveled for h more. So c plus h. So x coordinate will be c plus h. And what is the y coordinate? Of course, you put x as c plus h, it will be fc plus h. Okay. This is c, this is h. So this point is c plus h. What is the y point? Of course, put x as c plus h. Y is x for fc plus h. y is fc plus h. So now you have the x and y coordinate of both the points. Now the question here is, one is p, one is q. Now I want you to have this p and q together, because I am asking you only one point. Tell me at this point what will be the value. So what is the geometrical representation? I'm not talking about 2 points. Please remember, any point instantaneous speed, instantaneous value, that is at that particular point. First, let me find out the slope. What is the slope here? There is a triangle being formed. This is a point, this is h. What is this point? This is the y difference. Okay, what? Because the y point was fc and the above point was fc plus h. I'm taking the y difference because this is the y coordinate point. This is fc, this is fc plus h. So fc and fc plus h, basically fc plus h minus fc is the distance. So fc plus h minus fc is the y distance. And what is the x distance? It's h. So we have to find out theta. What is tan theta? Tan theta is perpendicular by base. That is fc plus h minus fc divided by h. This is tan theta. So this tan theta, now I am not asking about 2 points. I am saying just p and q should be together. 1 point I am asking. I want to give you only 1 point and you need to tell me the answer. So p and q has to be 1 point. So when p is q are together, there will be no h. There is no distance traveled because you have never traveled a distance. So p and q are together, so h will be 0. So you have to not put h as 0, but limit h tends to 0. H has to be very, very small. So limit h tends to 0. We cannot put h as 0, but this p and q distance is very, very small. So this is a slope. Tan theta is slope. Tan theta is m. Tan theta is the slope of what? It's derivative. This is the derivative. Basically, it's a slope of the tangent. So the derivative of a function f x at a point x equals c is the slope of the tangent to the curve y equals fx at point c in fc. So take that point, 1 point, that is c comma fc, mark a tangent, draw a tangent, whatever is the slope of this tangent, m, the value of m, and that is the derivative. That is the derivative of this particular function. Okay, so it's the instantaneous, any point I'm asking, you're very now confident to give me the value. Now let me give you an example of this particular thing, because only telling mathematics will not solve our purpose. So we have to find the slope of the tangent to the curve, and the slope of the tangent to the curve is given as y equals x squared. Y equals x squared. And you have point as minus 1 by 2 and 1 by 4. So how do we find out? So you have y equals x squared, the function is available to us, and also the point, there is the x and y point is also known to us. Okay, y is x squared, that is you are for fx having y as fx only, fx x squared. So essentially you are trying to find out f dash at point x, that is fx you have to find out. X point is what? In this xy coordinate, x is minus half. So you are trying to find out f dash minus half. I don't know what kind of curve it is. Okay, let us assume it to be any curve. So I have this point minus half and 1 by 4, and I'm trying to find out the tangent and slope of this tangent. And we know by the discussion we just had, what is the value of this tangent at x and x value. So fx you have to find out. Don't worry about the y value, only worry about the x value. So f dash minus 1 by 2, we have a formula. We just derived it. So fc plus h, so c, that is the constant here. As I said, you have to take the minus half. So this is minus half. H will remain like this. So fx plus h minus fc, this is fc plus h minus fc by h. So minus f minus half plus h, that is, this is your point, fc plus h, c is minus half, and limit h tends to 0. Now wherever you have minus half plus h, please put it in x square. So minus half plus h whole square minus, again, minus half, put in the function, minus half whole square. I'm just telling you the answer. So, because I just don't want to get into the detail of this solution, just come into the solution, h square minus h by h, you can take common, it is going to be minus 1. So the slope is minus 1 from the positive x-axis. So essentially, we have found out the derivative f dash minus half of this function, that is the value of this function and minus half, derivative. So this is minus 1 and minus 1 is nothing. What is this minus 1? Minus 1 is tan theta. When will be the theta of tan is going to be minus 1 at 135 degree from positive x-axis. So this is the physical interpretation and geometrical interpretation. Thank you so much. Take care of yourself.